Hello, I'm Robin Vincent and welcome to Molten Modular DIY. I'm back in the corner, ready to build some more stuff. Now, I'm going to throw a couple of kits together, just like that, because I'm such an old pro and all that. What these are from Frequency Central, and they're both to do with logic. So the thing is, I had this really great interview conversation with Steve from Thonk, and we talked about these modules as they were just about to be released, and logic is something that I hadn't really delved into in terms of modular. And so Steve said he'd send me a couple of kits, and he did, and I've had them for a little bit too long, and I thought it was about time that I put them together. They don't look difficult, they're not particularly big, deep modules, and so I thought I'd have a crack at getting them done. Well, not simultaneously, one after the other in a single video, because they're very much about the same sort of thing. So what we've got is the logic bomb. This is a dual module. There's two lots of logic stuff going on. And ultimately, well, I mean, obviously, as you can see, it's a Boolean logic module. The other one, the reset simulation, which is this fella here, is a two-channel thing with lots of outputs. So something goes in, you get 8 different sort of things out. Again, Boolean logic. You can tell I don't really know what that means, don't you? And you'd be right. I mean, the idea of building these modules is to get to the point where I can finish them, they're complete, and then I can use them and understand them. At this point, before I've built them, I've no real idea. Now, I do understand logic. I understand logic gates. I did electronics at high school for O-level, which was unusual back in the 1980s. And I understand AND gates, NAND gates, OR gates, NOR gates, that kind of thing. You're putting two things together and you're making a decision between what's going to happen. Are they both going through? Is one going through? Is it not going through? That kind of thing. That's the concept of logic as far as I, at a very basic level, understand it. How you use that in modular, I mean, if I think about it, I can see that, okay, so you could have a sequence going through or another sequence going through, depending on which one is active or high or gated or something. But in practice, I don't really know what that looks like. And so it's going to be interesting to get to the bottom of these modules and start plugging things into them to work out what the heck's going on. For the purpose of what I've got here, I've got a couple of hours spare, right? Spare's not really a word that I understand or use, but I'm going to cram this in. I've got a couple of hours. I'm just going to sit here, solder, talk about it, see how fabulous or awful the build guide is, and inevitably, or hopefully, I'll be able to highlight any of the issues, any of the problems, any of the tripwires, and give a good approximation of how you could yourself put these together. What I probably won't do is then an in-depth video about how they work at the end, because I don't really know. So we'll get to the end. Do they have lights? I mean, if they have lights, then hopefully we'll try to get some lights to go on, but otherwise that will probably be the extent of this video. I'm going to start with the logic bomb, and I'll do the reset simulation later. All being well, this might all change. It might take too long, in which case I'll split this video up. But I'm going to go ahead on the assumption I'm going to do this one in a little bit, in an hour maybe. And for the moment, focus on the logic bomb. And also, just before I begin, just to point out that these were sent to me by Steve from Thonk, thonk.co.uk, who sell kits and other bits of modular stuff and bits and pieces. They weren't sent to me by Frequency Central, but by Thonk. And that's awesome. And if you need a kit, you should go and check them out. So the instructions are online. We have a main PCB and a control PCB. Main PCB, control PCB. Good. You see, I already get the sense that I've had an impact. The very fact that the PCBs are labelled so clearly from the beginning makes me think that all my moaning in previous kits has actually had an effect. That's why I'm here. That's why I'm so flipping annoying. So, this is a Boolean logic module, 2 independent but identical sections. They feature addressable Boolean logic with any one of a not A, not B, and, NAND, OR, NOR, XOR, and XNOR being chosen either via knob or via CV input. When addressed via CV, the knobs become attenuators. How fascinating. So it says N on the board signifies certain transistors, Note the correct pin out shown by the half circles. Yep, I can see those. So here, here, here. Please observe correct polarity. Yep, cool. Here we go. Cool. Well, with Frequency Central kits, you get essentially a bill of materials, which gives you a list of what's going to happen, what's going on, the bits, and also a link to where they were purchased from, so that you can see that you got the exact right component. That should be true. Although this kit was provided by Thonk, so it's possible that they chose the components, in which case it may vary a little bit. But we'll discover this as we go. So we're going to start off with the main. So I'll put that one to one side. This is the main one here. Don't need the front panel for the moment. Don't need the knob tops. Let's put the hardware bits over there. Cable out of the way. Split things up. Uh-oh, headers. Some diodes, some chips, got some LEDs, got some resistors. Straightforward. I'm going to whiz through this, I reckon. So it says diodes and resistors first. Now with Frequency Central kits, you get everything written on here. So rather than trying to find a number on here and it relative to a list in the bill of materials, they've just put everything, the value of every bit and the name of it on here. So it's actually really quite easy to populate and then solder. So let's have a look at my 4 7s first. So I've got those. I can stick all of those in. So it says there's 4 10Ks and 6 4.7Ks. Now, strictly speaking, you could measure each of these and make sure they're correct, but I'm just going to go with the idea that Thonk know what they're doing and that these are right. Yeah? Got that? Got that. So there's 6 of those, 4.7, so that's these ones. Are they labelled? Just thinking about that suddenly. No, but those are 10K. In fact, I might even write on those. 10K. Is that worthwhile? Because I'm going to be putting them in something in a minute. I don't know. 47, put that on there. No, that's not 47, 4.7K. Right, good. And they've also got some 1K and some 100Rs. They're all on here. The front panel one, that has no resistors at all. So all the resistors and diodes are going to be going on this board. So that's good. That's easy. I'm going to do that. I'll see you on the other side. Not my finest work. I'm just kind of like trucking along. So I've got things to do, places to go, people to see. Well, not people to see, obviously. But let's just see how that works out. That looks alright. I snuck in the diodes as well while no one was looking. Just make sure that the line goes to the black line on the diode, and you'll get that right. That's all you need to do. Next it says IC socket. IC socket, this fella. Okay. With IC sockets, you just follow the picture. There's a nick out of it there, there's a nick out of it there. That goes in like that. The general concept we're trying to follow here is that the smaller, lower things get installed first, so that when you turn it over to install something, it's not going to be raised up and the thing's going to fall out. So you start in height order. Height order is the plan, so we're just going to pop this little fella in. So I'm going to want that to sit straight and flat, otherwise it won't be flat on the other side. So I just want to stick something underneath to hold it up. Too much. That's a bit better. Going to hold it flat with my fingers. Solder in one corner if I can get that to work. Go on. Nope, got that wrong. Try that again. That's better. One corner in. Turn it back up the right way. See that it looks more or less straight. Yeah, Good. Then do the rest. Start on an opposite corner, I would. Great. Excellent. Non-electrolytic capacitor. That's going to be in this little bag. So we have a couple here. Got these ones which are electrolytic. Electrolytic means they have polarity as much as anything. So those are not the one, whereas this is going to be the one. Now if you have any doubt, you can go back up to the bill of materials. But what we're looking for on here is the 100 nanofarad. It's labelled on the board, 100 nanofarad. Doesn't have a positive or negative, so that's going to be the non-electrolytic one. And if we go to the 100 nanofarad here and have a look at the picture of what was purchased, then this is definitely the right one. It doesn't matter which way around it goes, just pop that in there. Solder it in. Okay, next it says the 78L05 and the BC547s. They sound like chips. Yep, they are. Look at that. They're written on the big packet. So let's have a look in here. Try not to rub any balloons on your head. And handle them with, with suitable care. Alright, so there's 4 BC547s, which are going to be these. There's a firmware chip. And a TL072, which is that fella, I think. Yep. So the 3-pronged one must be the 78L05. Let's have a look and see what we've got. So we were told that the ends on the board, 1, 2, 3, 4, refer to the BC547s. I'm going to go back and check that. And the way you put them in is simply so that the half circle matches the half circle that's on the board. Not difficult, not tricky. The trickiest thing is getting that masking tape off. So just make sure that it's the same way as it's showing you. Just bend out a couple of legs. That should stay there all right. And one goes one way, one goes the other. Interesting. Now the 78L05 is this one here, which is the single one which is on its own. It's going to be really hard to get this wrong, I think. Except it just needs to widen those legs a little bit. See, it follows the shape of that semicircle. That's all in. Let's do those. Good. Next up is the power box header, which goes there. Sure that's going to be taller than the other bits? I suppose it is. Oh look! Oh look, I forgot that one. I thought, for some reason, I thought that went on the other one. Completely nuts. Right, so that's got to go there. Like that, so it goes the right way around. Now I've got the classic problem where when I turn this over to do it, these taller components are going to mean the whole thing's just going to fall out. Isn't that awesome? Great. Super. So how am I going to cope with that then? Well, masking tape I guess is the answer. Can I see any? In which case, what am I going to do? Can I see any masking tape? See, I thought I'd started using masking tape now, like a good boy, like I'm supposed to, like people say I should. So where's that gone then? Found it. Right. Bit of this. Stick that there. just want to tape it down as much as possible so you think it's going to stay. Tag a corner. Give it a quick look. Well, it's not completely flat, but it's flat enough. Flat enough. Right orientation. Yes, did that bit right at least. Come on, keep it together. Great, now where was I? Putting this bit on. Now you've got to make sure that the square points towards the square. There. Yeah. Good, good. So turn that one over. Again, that's probably could do with a little bit of being pushed up, but I think my soldering iron is going to do that. If I push down on here, that holds it nice and steady. Get that tacked on. Keep it held as I take it off. So that solidifies, that stays, lovely. Now the electrolytic capacitors, which are these fellas here, long leg is positive, long leg positive, short leg negative. See the negative on there, long leg positive. So I've got two big fat ones and one smaller one. So I've got 47, 47 and a 10. So the two that are the same are going to be 47. Yeah, and that's what it says on it. So the positive they've given to that square one, so the positive is the long leg positive. This one, which is the same, long leg positive. This one, the smaller one, long leg positive. Great, that's done. That is done, except for the flipping headers, which I hate the headers. Oh, I hate the headers. Hate the headers. Right. Cut the male headers to size, solder them in place. Make sure they stick out of the bottom of the PCB. So they want these ones. These are the males. The spiky ones. Spiky ones are going to go there and there. And they are, of course, just one too many. One too many. So I'm going to have to cut that off. See, one too many there. Just have to cut it. That's all you can do. Ow! And the other one too many, put something there. Whoa, that flew across the room. And these go on the underside because they're going to be sticking in to the control board into the sticky in one. Yeah, so sticky out to sticky in. Sticky out goes on here and here. Now if I'm clever, I can turn these over and they'll be awesome. How likely is that? I don't know. Let's just try it, shall we? Alright, so that's good. That's pretty good. Now we're just going to try to make them rest on themselves to give me a chance of soldering them in straight. Let's do a leg. Oh, as it goes, that's not too bad. It's not too bad. That's alright, I think I'm going to get away with that. It's got a little bit of lean to it, but I think we can cope. I think that's not too bad. Right, let's go all the way along. Good. Super. Let's put our chips in while we're here so I don't forget about them. So the little bit on it refers to pin 1. I've got a little tool here that helps me with the legs, because if I put this here, it doesn't actually fit. The legs hang over the edge, so I'd have to bend them in. This little tool here allows me to do that without messing it about. So I just do that, squish it, the legs are squished in a little bit, pin 1 is over there, And then that drops in, sweet as a nut, sweet as a nut. This thing, the same. The logic bomb, logic, something, whatever it is. Pin 1 is where the nick is. Pin 1 is where the bit is on there. Put that the right way round. And... oh, did I screw that one up? No, there we go. That goes in nice. Goes in nice. Good. That's the main PCB done. Right, now onto the hardware. Or the control. Solder the 2 metal shaft pots. Pots first? Really? Are you crazy? Then solder the sockets. Well, if no one minds, I'm going to do sockets first. Otherwise, they'll all be the wrong height. So these sockets here, they've all got sort of a support leg and then the 2 legs they go into. So they just fit quite nicely into that hole at the front. That kind of holds them slightly under tension. Slightly. And there might well be a reason for doing these first, but I can't see. If I put that in there, it's just going to be too tall, and then these are going to fall out when I turn them over. So I'm not going to do that. I'm going to do it like this. Then I'm going to get a nice piece of something or other to help me turn it upside down. Without them all falling out. There, they're all flat, not necessarily straight, but flat. And let's stick them in. According to the underside of this PCB, there are 10 types of people in the world. Nothing like a bit of philosophical thinking while you're soldering. Good, now the 2 pots. Fit like that. And like that. Balancing a little bit. Oh. Good. Now I've got to do the female headers, the socket headers. These have to go in like this, and I have to get that the right length. Oh, like so. So I'm going to need to cut down there with something. Alright, so I blew that completely. I am missing a leg off the side of there. So I did that poorly, sadly. I do hate this so much, the cutting of these things. Okay, that went away. It's one too big. What am I doing? How am I getting this so crappy at the moment? Alright, that's one too big. Dear oh dear. I have to have a better solution. Can't we just have headers cut to the right size? That's my question, ultimately. Maybe I need some different form of something or other. That's one. But this one is too small and I've lost a bit off the end. So I'm going to have to dig out one from before. So if you do this, if you mess this up, you're kind of screwed. Alright? Now I have some spares from other projects, I think. Oh, I don't know. Do I? I forget what these are from. But let's see if I've got one that will be the right size. No, that's one too few. No, one too few. These are all going to be too few. They're 10 way and I need an 11. Okay, don't know what to do at this point. So, I mean, it's possible that I could get this to stay in there. But my best bet is going to be... Come on. Fudge it. You can do this. I hate these things. It just requires a pin to go in there, doesn't it? That's all it's after. So this has to go onto one of these. So if I put this on here, like so. Is this a complete waste of time? Not sure. All I need to do is get this soldered in on the other side and it will work. That's all I need to do. So let's put that on there. Now which way round is this going to go? I'm going to assume that the writing goes the right way round. Something here to say anything? No, that's it. So we're going to make the assumption that this goes round the same way as the writing. So let's see whether I can rescue this by getting this in here. Cool, well, you know, got to give it a go, haven't you? Got to give it a go. See if I can make that stay. So I guess the moral of the story is cut the socket headers further away, and then I guess gradually cut them back with a knife or something until you get to the size you need. I don't know. It's always a faff. Right, so if this stays together when I put it apart, then I might have gotten away with it. Seems to have done. Let's go with it. Go with it. We are flying by the seats of our pants. That's awesome. Right, so what did I get to? Got to the LEDs. They're here. And we now need to use the front panel in order to help us with this. So with the front panel, I get all my screws, take all the screws off these patch sockets, and then put on here the front panel. My patch sockets are a little bit off. There we go. Cool, how did I do such a terrible job of that? Maybe I should have done all of the soldering with these on here. Yeah, I should have put the top on to do it. That's what I should have done. Could have done that. Could have done that. Right, there's one in particular which is giving me trouble, so I'm going to take this one out. Still not entirely there. Okay. Right, that's in. Let's put a couple of screws on to hold it. Okay, now the instructions do say that I should use the panel to ensure they line up nicely, and I failed to do that entirely by not reading the instructions quite closely enough. So that's all on me. But, you know, there we go. Let's make sure I solder this back in again. Every DIY kit is a bit of an adventure. Now, this is all about the LEDs, which I have forgotten to put on. Oh, my heart alive. Here they are. So I want to put these on before I put the panel on. So let's take those screws off again. So we've got red, green, red, red, green, red. Long leg positive. Doesn't show me positive on the LEDs. That's a pain. That is a pain. So I'm either going to get these all right or all wrong. Now with these, the square hole on the electrolytic was the positive. You can see I've got a square pad and a circular pad. The square pad has at this point been the positive one as far as the capacitors go. So I'm going to take that lead and make that assumption for the LEDs. Solder the LEDs, make sure they line up correctly. Doesn't say anything else about it, does it? No. How annoying. How very, very annoying. Now, the picture could tell me, because there's also a slight flattening on the shorter leg. See, that's round on that side. Yeah. Alright, so through process of trying to look hard at that picture, having no other information to go on, really needs to go in the manual which way around these go, because that's really easy to get wrong, considering the inconsistency that on the capacitors the square pad was positive, whereas with these it's looking to me that the short leg, which is negative, is the one that's on the square pad. So it's the opposite. I mean, maybe I'm being ridiculous. Am I being ridiculous? It's a diode. You have to know which way round it goes. You have to. It's really important. I'm going to go with it. If I have to take it apart, I have to take it apart. No point crying over it. Okay, let's try to get these back on again with my beautifully lined up everything that I flipping failed to line up. Oh, come on, you there. And then with a bit of luck, when I turn this upside down, all these lovely LEDs are going to fit in their holes. Like so, beautiful. Good. Right, that doesn't have to come off again. I just have to put this on. Presumably, as I say, the right way round, so that the writing's the same. Goes in there nicely. That seems to be hanging together. Got the chips on. Need to put on the rest of the hardware. Okay, the knobs are just slide-on ones. They haven't got nuts or anything. They just go the right way round for it. You can feel that. And put it on. That's that one. And that one. And there it is. The logic bomb. So that was no fuss, was it? Oh my goodness me. What a palaver, eh? What a palaver. Just don't know. Next up then, the reset simulation. Ins and outs. You've got an and, an or, XOR, and a XNOR. Fantastic. This one I'll try to remember to put the front panel on when I solder the sockets, because this is mostly all about sockets, this one. So I think that would be good. Let me do that. More flipping headers. Woohoo! Love those things. Love those things. So resistors, a few more diodes, a bunch of hardware. I can stick that away out of there. Let's see what I can pull out of the instructions of this one. Reset simulation, main PCB. The one that's got frequency central written on it. Control PCB is the other one. See that there, kiddies? Yeah, good, got it, good. So the key to the screen print is that N signifies the BC547s again. Please observe correct polarities. I would love to if we knew what they were, sir. Now there's a picture of kind of the finished product with this one to the side. Yeah, that looks all feasible. So main PCB, which is this one, put that to the side. This one fella here. Diodes and resistors, IC sockets, electrolytics, and then the horrible headers. Good. Well, I've got resistors and diodes here. It's all printed on the board. 10K, 27K, 100K, etc. They're all printed on here, so they're easy enough to get across. The numbers of them that there are will tell me what the values are. I don't need to measure them. Great. I will get stuck into that and I'll see you on the other side. There, resistors and diodes all on nicely, I think. Then it's very similar to the other build, the non-electrolytic. And I guess there's going to be some similarities because it's going to be using similar chips, similar circuitry, because it's all producing this logic stuff I keep talking about. So this is the non-electrolytic capacitor, which is the 100 nanofarad one, which goes on there. Stick that in real quick. Then it wants the IC sockets. The two IC sockets, unlike last time when I only put in one. Let's see if I can put in both at once, and I've already messed this up by putting in that non-electrolytic. Never mind, we just keep on soldering on. You see, that's where the expression comes from. But you didn't know that, did you? But you thought it was a military term, but no, something to do with soldering. God darn it. Right, I'm going to turn that over on there. Is that going to be helpful? Put that there. Maybe. Let's go with it. Just trying to get that. Trying to get a corner of this done. Okay, that's the IC sockets in. The capacitor. Now let's try this little bundle of fun. Right, we've got two things together which are going to be the BC547s. Two of those. The other two are the similar chips to what we had on the other one. So let's go with these first. These go into the little N bits. No, they don't. Oh, they do. They're also labelled with both on this particular one, which is nice. So I've got the N and I've got the fact that it's a BC547. So make sure it goes the right way around. like that. Now, there's probably another one in here. There is. There we go. And this is the 8L05. Which goes here. Power header. Make sure it goes the right way around. Good. All the electrolytic capacitors, I've got 1, 2, 3 of those. So that's two 47s and a 10. So the bigger ones are the 47s. Long leg positive, once again on the square thing. (47, 47), long leg positive. Long leg positive on the 10. Oh, see, that's a bit shorty, that one. So are they, but oh, who knows? Who cares? A bit smaller than the ones on the diagram. It's those flipping headers that are fast. Oh, just stop that. That are fast approaching that I've really got to worry about. Good, so that's all done. Let's stick these chips in. Get my natty tool, give it a squeeze. Make sure it's the right way round. A little nick goes a little nick. Goes in there. Goes that way around. Oh, misbehaving. No, that's in. Good. Now, Bleedin Headers. What have I got again? So, I need to take one off here. That's the easy bit. What I could do, I was just thinking to myself, if I plug that in there, is that going to make it any easier to try to carve away? No, because then I'm pushing against pins, aren't I? But I could potentially I know what I mean by that. Oh, look, that worked. That worked quite well. Right, try that with this other side. That's one too big. Take one off. You beauty! Did that alright that time. Did that alright. So, that end in there, I don't suppose it really matters at the end of the day which ones go in and which ones don't, if it's the spiky bits or the other bits, so as long as it goes in. So I'm going to do that. Now the problem is, because they'll be sticking out either way, won't they? You want it to rest where you can feel that it's flat. Am I still talking? Seem to be. Good enough. And when these go onto here, that's going to be completely lovely. Right. Did that bit. Control assembly. Let's see if I can get this bit a bit better. So, 10 sockets. Use the panel to line it up. Good idea. Let me do that. So, 10 sockets. They've all got to have their little screw taken off. Now, I'm going to stop here because I've just noticed there's a whole bunch of resistors that need to go on first, which it doesn't mention at all. It doesn't mention them at all. Now, this does come up with Frequency Central kits, I have to say. In the Rick, the lovely guy who puts all these together and makes them and designs them and stuff, he's just a little bit too good at it. And so that means that he forgets, sometimes he just forgets the simple stuff. Like putting a plus sign on those LEDs, for instance. Or saying in the thing, install the resistors first. Because he said that before on the other PCB. Install all the resistors. And so he's kind of assumed that's carried across to the other PCB, even though it wasn't expressly mentioned. And now here we are on the other PCB. It could say that since you've already installed the resistors, etc, etc. See what I mean? See what you mean? But he's not into lots of talking. He just likes getting on with stuff. So he makes the assumption that we know a little bit about what we're doing, which in my case is a worry and a challenge. And that's where we are. Alright, so 4K7s. Let's put a bunch of these on. Right, good. Back to putting these on. Now I have noticed something as I was soldering on the resistors, and that's that the LEDs actually on here have an edge. They have an edge, a flat bit, and that corresponds to the flat bit on the LED. Now looking back onto the board on this one, the logic bomb, it is also there. It's just not as pronounced, and it does look like it could just be the way that the print has gone into the next the next component. So it's not very clear. Now it is on there. There's no doubt that it is actually on there, but it's so slight that if you don't know what you're looking for, if you're not expecting to see that, if you're expecting to see a positive or something a little bit more obvious, then that's gonna trip you up. Now that I know, do I know whether I did it right? I don't remember. And I can't sort of pull that apart now in order to see. So it's just going to have to be as it is, and if it will work, it works. If it doesn't, I'll have to take them all out, turn them round. I think, as luck would have it, I got it the right way around. So that's always the fun bit about my little rants, is that sometimes they're valid, sometimes not so much. But, you know, it's all part of the journey. It's part of the excitement of putting something together. So this time around, I'm going to put this on top. So that will ensure that... Oh, there's the left one on. Dipstick. That they... you know, it doesn't matter how wiggly they are, as long as the actual sockets are centered on here. See, that's better. So much better doing it like that than doing it the other way, you idiot. So just a couple of nuts on to hold it, and it's a beautiful bit of soldering. Beautiful bit of soldering. There's one that's not there. What was that? How's that one? How did that happen? God, I'm a disaster. I'm never going to get this done before tea, am I? Come on. Come on, come on. Back on. Nearly there, just the LEDs to do after this. Right, I'll see you in a minute. Right. Take the front panel off again. Those are all beautifully wiggly on there. We'll do this panel bit first. Because this all has to go on here, doesn't it? Like I'm asking you. Oh, I've done this wrong. I've done this so wrong. Oh my goodness me. So this is the front, right? So this has to be this way round. I've done that completely wrong, haven't I? Shouldn't that be like that? It should. Oh my goodness me, look at that. Completely, no. Have I? No, I haven't. Or maybe I'm just losing my mind. I think I'm losing my mind. Yeah, no, I have done this backwards. Have I? Yeah, I completely have. This should be, shouldn't it? Hang on. No, that's as that. No, I'm doing it right. I just suddenly got a flash of something trying to tell me I've done this wrong because of that. But then because of the power cable is what made me think that's sticking out the back like that. And it is sticking out the back like that. What I've got to do is solder all that and solder all that. Fine, that's all fine. It's all fine. Definitely losing it. Okay, that's lovely. All came apart perfectly well. So the flat bit on this is referring to the flat bit on these. And the flat bit is the short leg. Which is going to be negative. So short leg, flat, short leg, going to the flat bit on the PCB, which is on that square pad. Which again is the opposite of what happens with the capacitors. So short leg to square. So green all the way along this end, short leg to square. Good. They're all in. Put this fella on. Turn it over. Get all those LEDs in the holes. Looking good. We are nearly there. So there, looking pretty smart. This one is going to go on. I'm going to make the assumption again that it goes the right way round or the right way up. Who knows? Did I do that when I soldered it? I have no idea. Like so. Power cable in. So there, right there, is a pair of frequency central logic modules. Logic bomb and reset simulation. Are they fun? Are they interesting? I have no clue at this point. I would like to say though that the build itself, the soldering, the layout, all those sorts of things were not difficult. Not difficult at all. Lots of space on the boards. Lots of room for soldering. A good sort of entry level, just about an hour's build, I would have thought, on one of these. Do need to pay attention to the instructions, of course. That LED thing still annoys me rather, but I can see that it's my fault for not looking at it quite close enough. Although a little bit more help, I think, would be appreciated. We always need more help than you think, you builders of modular kits. Yeah. So I've got to shoot off and make the tea, and so I'll leave checking these out and looking at them and testing them and things like that for another time, which you'll probably see in a minute. All right. Right, we're back. Late at night. I've just finished editing down the video of the build of the two frequency central logic modules. And crikey, it wasn't my finest hour, was it? I mean, I was crashing my way through all sorts of difficulties, not putting the front panel on, not understanding the LED markings on the PCB. Oh, didn't really bring my A game to that one, I don't think. Not to worry. Not to worry. Moving on, because it's done now. Got them together. I've put them in here. I've turned it on and all the lights have come on, which means first and foremost that those LEDs were the right way round. Yay! Now, what you're kind of expecting is for me to give you a bit of a demo, except that I'm not entirely sure that I have any clue as to what you're supposed to do with a logic module. So, well, I mean, by way of testing it, what I can grasp so far at a fundamental level is that you have a logic gate does a simple piece of maths to compare two things and decide whether it's going to let something happen or not. Now this, as far as I can see, is all to do with gating, really. It's to do with patterns. It's not to do with melody or control voltage in a modulation sense. It's to do with turning things on and off. And so with a logic gate, you have two things affecting a third thing. So two inputs, one output. And depending on what the logic gate is set to, gives you an output depending on the inputs. So for instance, if you had an AND gate, input 1 and input 2 have to be lit in order for output to output something. Yeah? An OR gate means that either or can be lit and that will do something out. And there's lots of other versions of that. But I'm just going to bring you in. I'm going to show it to you. And I've got a very simple idea set up here with a drum and a synth. Yeah? you get this sense I don't have any clue what I'm talking about. Whoa, easy now. I have a little bit. Let me show you. So here we go. Let's focus on the logic bomb to start with. Take out my output for the minute. So I've got two things going on. I've got a kick drum and a snare, both being run by the little LAL8 module over here that you can't quite see. And I've multed them up, so I've got them going to the Queen of Pentacles and you can hear the sound. Kick drum and a snare drum. So I've doubled up those outputs and I'm going to bring them as inputs into the logic bomb. In one. So that's the kick drum flashing away, and this is the snare. Now, depending on what I set on this knob here, I've got not A, not B, and, NAND, OR, NOR, ZOR, and ZOR-NOR. Now, I'm not going to tell you what each of those are necessarily, I'm just going to demonstrate what happens. So I put this, now this is opening a gate on the veils here, which lets through a sequence or a note from an oscillator that's being run by this little 8-step sequencer. So as an AND gate, when you have both the red lights flash, then you get the third light flash, and that's this output here which is going to the veils, which is letting through the sequence. So if I change it to an OR, you'll get the sequence happening on every single time either of them go. These other modes do something else that I'm not entirely sure of, but the point is that by changing the logic you get a different pattern coming out that's derived from the two things that are going into it. Interesting, eh? Now if by way of testing, we're going to test the reset simulation as well. So that's input A. Input B. Look at all those lights flash. Isn't that fantastic? So what output do I want? Do I want an AND gate? There's one. Do I want a NAND gate? So that's playing all the time, except for when they both happen at the same time. So I guess the idea of the reset simulation is that you've got all of these patterns coming from these two inputs that you could run into all sorts of different things. But the point here is not to dazzle you with my in-depth knowledge of logic gates in Eurorack. No, it's just to show you that they worked. I plugged them in, they worked. No bother, the LEDs came on, no smoke, nothing crazy, nothing broken. It just appears to function as it's supposed to. And that's an awesome and pleasing thing. Now what I'm going to do is I'm going to spend some time with them at some point, sit down and work out what logic is all about, what it could be used for, because even though I understand the concepts, and I think the little demonstration there was already starting to unravel in my head as, oh, yeah. But I'll do some proper research, right, and come up with a few ideas, get some stuff together, and then I'll do a video all about logic featuring these two modules, and hopefully we'll find something that could be useful. Apparently they're really useful, particularly for drum patterns. I mean, the one thing that I keep coming back to is what if I want this third pattern derived from these other two patterns? Why don't I just write the pattern that I want in the first place? Or maybe it's to do with the variation, the fact you can change from one to another. Or maybe like with this one, I've got 1, 2, 3, 4, 5, 6, 7. I've got 8 patterns out of 2 patterns. Maybe it's an economy so that I only have to write 2 patterns and I've got 8 patterns relative to each other. Maybe that's it. I don't know. It's going to be interesting to explore, and I'm quite into that, because I sense that underneath there somewhere is something that could be very useful in a setup. A very useful way of making a sudden change, a variation, and that always appeals to me. So there you go, the logic bomb and the reset simulation build from Frequency Central. They work. Build was all right. You just got to keep your wits about you, man. I've got to get better at this. So cool. And in the meantime, go make some tunes.